This question is about how a circular loop behaves in a uniform amplitude signal, and the question wants to find the peak magnitude of B when an EMF of 30 millivolts is developed inside this loop. So we first want to start by talking about time varying signal, and because this is a uniform amplitude 300 megahertz signal, the formula you want to memorize is Bt, which is a magnetic field that varies in time, is equal to B naught times sine omega t plus phi naught, where phi naught is equal to the phase shift. However, because the question does not involve phase shift, we could disregard this for the scope of this question. So what we're interested in is uniform amplitude. And uniform amplitude, Bt, varies in time, is equal to B naught times sine omega t, where there's the angular frequency is equal to 2 pi frequency, which the f value will be 300 mega. And we know from this equation from the ECE 221 formula sheet that V electromotive VEMF is equal to the negative change in flux. Again, VEMF is equal to negative d phi dt, which is equal to, so the change is equal to area, negative area, and then the B comes in, not, and cosine of omega t plus omega t. And this is because you're trying to take the derivative of the Bt function with the derivative of the function with the area, and the B naught comes in here, and the sine function becomes a cosine with a negative in front. So like this, omega t. And we know that this one wants a maximum response. For a maximum response, because of how cosine is. So it looks like the maximum value of a cosine would be a 1. So this will, we know that the max is equal to 1. And if we rewrite this, it will peak this time. VEMF is equal to as area B naught omega. And here area is given to be 0.02. B naught, we have to find it. Omega is equal to 2 phi 300 to the 10 to the 6 for the mega. And if you solve for, it's also given that the peak value is 30 millivolts. 30 times 10 to the minus 3. And if you take this is your only unknown. You solve for B naught. Find that the B naught value would be equal to approximately 8.0 times 10 to the minus t Tesla.